Okay, so Leetcode practice time. So in this video there are two goals. The first one is to see how we are going to solve this problem, and the second one is to see how we should behave in a real interview. Let's get started. The first step in a real interview is to try to understand the problem, and also if there's anything unclear, please bring up the question. So don't feel shy, and also at the same time think about some edge cases that can break the general algorithm. So let's take a look at the question. Number of subsequences that satisfy the given sum condition. So given an array of integers nums and an integer target, return the number of non-empty subsequences of nums such that the sum of the minimum and maximum element on it is less or equal to target. Since the answer may be too large, return it modular by 1 billion plus 7. Okay, so example, input array is 3, 5, 6, 7, and you have the target as 9. So output is 4 because we have 4 different subsequences that are eligible, which are listed below. And also, based on example 2, it seems like we treat duplicate numbers as different elements. And also, based on example 4, the input array is not sorted. So the constraint says the input array could never be empty, and the maximum length is 100k. So the number and the target are within 1 to a million. Then I think we don't have any edge case at this moment. Let's think about how to solve this problem. So the solution is, first of all, we sort the input array. So let's say we sort suppose the input array contains 4 numbers, 3, 5, and 6, 7. After we sort it, it is something like 3, 5, and 6, 7. So we will keep 2 pointers, the left pointer and the right pointer. So the left pointer starting at the first number at the very beginning, and first of all we initialize the right pointer towards the end of the input array. So we will move at this point, we will try to move our right pointer towards the left side until we find the first number pointed by the right pointer, the first number pointed by the right pointer that sum up with the number pointed by the left pointer and has a sum smaller or equal to 9. So in this case, we will try to move our right pointer towards the left side until we find 6. You see that the minimum plus the maximum, which are the two numbers pointed by the left and right pointer, so the sum is equal to 9. So at this time, we see that we have 4 different options here. So because every time we need to keep the left pointer, the number pointed by the left pointer, we have 2 options to keep for number 5, which is whether we keep it or we drop it. Same for number 6, it's like whether we keep it or drop it. So the number of options is 2 times 2, which is 4. And next time we will move our left pointer towards the right side by 1, and we initialize the right pointer to be the end of the array. So the same thing, we try to move our right pointer until we find until it moves out of the range. When I say out of the range is the right pointer falls before left pointer, or we find a number, the first number that sum up with the number pointed by the left pointer, the sum to be smaller or equal to the target. So that's essentially the idea how to solve this problem. So the runtime is unlogin because so the runtime for the sort is unlock n, and for the second process, which is like the process we just talked before, so we will have for the maximum we will move left pointer like n times, and for the each move we will try to find the right pointer, the proper right pointer within the array. So based on what we mentioned before, it's like n squared for the total runtime regarding the process. But we could optimize it by using a binary search to find the proper right pointer for based on a fixed left pointer. So in total, if we use the binary search, the total runtime is still going to be n log n. So let's do some coding work on this approach. So for coding, we care about the correctness, the readability, and also the speed. So let's do some coding work. First of all, we will see. Let's see. So first of all, we will create a. So first of all, let's define a constant. Let's say it's the k mode as equal to 1 2 3 4 5 7 8 9 1 7 8 9. Okay, so it's 8 zeros, so we missed the 7 here. Okay, this is the k mode, and let's define an array. Call it let's call it num sub. So as equal new int nums.length. So what is num sub? So the num sub essentially it is how many. So suppose let's use an example to explain this. Suppose we have fixed number as 3, and let's say our pointer is pointing to 6, which is the third number within the array. So we have two options here. So whether to keep 5 or drop the 5, and we also have two options for 6, whether to keep it or not. So suppose within the window managed by the left pointer and right pointer, there are 3 numbers. So there are actually 2 to the power of 3 minus 1. So we have actually this many options we could choose from. So it would be something like 2 to the power of r minus l. So this is essentially what we want to keep in num sub. So num sub 0 would be 1. So this is essentially saying what if the left pointer and the right pointer are pointing to the same number. So there's only one option for us to choose from. Then we have I is 1 as smaller than nums.length plus I. So num sub I is equal to let's say num sub 0, move to the right, just move 1 bit and divided by the k mode. Alright, so no, so this should be I minus 1. So I is equal to I minus 1 times 2, then modular k mode. Okay, so I think that's fine, that's correct. And then we are going to follow the process we introduced before. So we are going to keep the left pointer. The left is smaller than nums.length plus I, and every time we need to find the right index. So let's say we define a helper function. Let's call it find the right. So we are going to pass the input num array, and also we are also going to pass in the number we are trying to look. So we are actually trying to look at target minus nums left. So if so actually if the nums left is if nums left is larger or equal to target, we can pretty much just break it. And we also need to have a sum. Sum is how many number of the eligible subsequences are there. And we'll find right. So if the right index is actually smaller than the left index, we just need to continue. Otherwise, we will have sum plus equal to num sub, which is right, minus left. And finally, we return sum. So let's further implement the helper function, which is find right. So we have the nums and we have the target. So this is like binary search. First of all, for binary search, we have the L pointer, and we have the R pointer, which is nums.length minus 1, and we will have the mate pointer. We just don't define the main pointer here. So well, the left is smaller than the right. We have the mid as equal to L plus R minus L divided by 2. And if the nums if the nums L is smaller or equal to the target, so if the target is larger than the made, so if the target is larger or equal to made, then we need to have L as made plus 1. So otherwise, if the target is smaller than made, then we will have R as equal to made. And finally, we need to return. So suppose we find the target number, then we just return L. But if we don't have the target number, L is actually, it could be the next larger, the number a little bit larger than target. So we will have to say return nums L is larger than target. If yes, then we have L minus 1. Otherwise, we just return L. So that's pretty much about the code. Let's see, I think we have missed something here, which is we are going to do some modular here. Otherwise, we may overflow. So let's see. After we are done with coding, it's time for us to do some testing. So num subsequences, nums and the target. Let's use this example. So first of all, we have num sub initialized as something like 0, 2, and 4, and 8. And then sum initialized as 0, left is equal to 0, towards the end plus the left. And if nums left is larger or equal to the target, then we just simply break. Otherwise, we will find the right index based on the target and the number pointed by the left pointer. And if the right pointer is smaller than left, then we are just going to continue. Otherwise, we have sum plus equal to sum plus num sub of this and divided by kmod. Okay, I think overall is fine. So let's take a look at this one. So let's see if we are trying to look at, let's say 3, 5, and 7, 8. let's say when we try to find 6, what would happen? Let's say when we try to find 6, then first of all, L is equal to 0, and R is equal to 0, 1, 2, 3, 4 is equal to 4. So first of all, made is equal to 2. So made is equal to 2. It is pointing to 7. We see that 7 is larger than 6. So we are going to have R to be equal to 2 at this moment. And next time we have made as 1, and we see that 5 is actually larger, so we have L as made plus 1, which is 2, and then we break. So finally we have nums L, which is equal to 7. Actually it's larger than target, so we are going to return 1 here. So let's see if we are trying to look for 8, what would happen. So 0, 4, and then when we compare the made number, it's actually smaller, so we are going to have L as equal to 3 here. So when L is equal to 3 here, the made is equal to 3 as well. So we see that it is still smaller than the target. Then we will have L as made plus 1, which is 4. So and then we break. So similarly, so we are looking for 8, and L is equal to 4. So we are going 1, 2, 3, 4. So we are going to return L minus 1. Okay, we are going to return 4 minus 1, which is 3. So I think it seems to be right. So when target number doesn't exist, we are just going to return the number that's a little bit smaller than that. Yeah, so let's give it a shot. Okay, it says the wrong answer. Let's see why it is wrong. So for this one, okay, so we haven't actually sorted the array. So first of all, we actually need to erase .sort. We should have sorted, otherwise it's gonna be completely wrong. Yeah, so now everything is good. So let's do a submission for it. Yeah, so everything is good now. So I made a couple mistakes before, and I submitted a couple times. So I'll tell you what I did wrong. So for the first mistake I made wrong is I made a typo for here. So I typoed it as 1 billion plus 9, which is wrong. So I made a couple mistakes, mistake summation based on that. And also I missed one thing here, which is I just did something like sum plus equal to this one, and simply it will just overflow. So those are the two places I did wrong. So I hope you don't make the same mistakes in your interview though. So that's it for this coding question and the solution. So if you have any question about the solution or about the coding puzzle, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.